Imagine you're at the party and you don't know where the bathroom is. Now you could ask just one person, but what if they were wrong or they misheard your question? The thing is that you have this huge Taco Bell lunch and suddenly you got to find the bathroom. So you decide to ask a bunch of people. This is what we call a random forest algorithm. Instead of relying on one decision tree, that is one party goer that perhaps might or might not know where the bathroom is, you rely on many party goers, that is a forest, to make a decision. Eventually, each person you ask, that is each decision tree, has seen different parts of the house. And your waiting time to actually find the bathroom might possibly be less. We call the different parts of the house the different subsets of data, and the different ways of giving directions, different decision-making rules. Some might say, turn left at the plant, while others might suggest, go past the kitchen. You don't just listen to one person's instruction. You consider all their advice and go for the majority vote. If most people point you towards the corridor, you'll go there. You'll make it to the bathroom in time. Even if one adamant person swears you need to go back door and climb a tree to find the bathroom. This is how a random forest algorithm works. It asks a bunch of decision trees made from a random subset on the data and uses their majority vote to make the final decision. And hopefully, just like you at the party, it ends up in the right place more often than not. Just remember, no algorithm or party goer is perfect. Sometimes you might end up still in the closet, but at least you're not climbing trees in the backyard. We will start by importing our usual libraries. Import numpy as np, import pandas as pd. From Scikit-Learn, we'll get the model selection and import train test split. From Scikit-Learn ensemble, import random forest classifier. From Scikit-Learn, we'll import as well the datasets that we're going to be using. From Scikit-Learn, we'll import metrics and import matplotlib pyplot as PLT. So once we've loaded these different libraries that we're going to use, we're going to load the iris dataset, which is part of the Scikit-Learn library iris equals to datasets.load_iris. We can now convert the datasets to data frame using the pandas library for that. Iris, target, column, feature, names, plus target. So we will split the data into features and targets, and we'll do so by defining x equals to data frame iris, and we'll be using the feature names that we've got, and so that's what pertain to features, and then we'll use the y where in our data frame we have the target, and this would pertain. Okay, once we've done that, we are now ready to split the data into training and testing sets. Xtrain, Xtest. And you might remember this is similar to the other videos that we've seen where for the logistic and the linear regression, we've already done that. And we'll do train tests split for x, y, and use a test size 0.3. Based on this, we can now create the random forest classifier, and you will see that once we've split the data into training and testing, we usually call out the different classifiers that we want to use. In this case, we are calling out for the random forest classifier, and we'll use a number of estimators of 100. Train the model finally using training sets and SCL fit of the model for Xtrain and Ytrain, and we will see how it works. So Y, and we'll predict, and we're going to be predicting the X test. Can check the accuracy and see how it worked out. So print accuracy loaded from the library, accuracy score for Y test and Y. Our accuracy is 0.96. Thanks very much for watching.